In this video, we will review the code for LinkedBag, which is the class that implements bag interface. So this is a different implementation than ArrayBag, but this class will implement all of the same methods as defined in bag interface. So all of these same methods will be implemented in LinkedBag, but instead of using an array for an underlying data structure, instead we use linked nodes. So we have two instance data variables. One is just a node pointing to the first node. So remember that when we're using linked nodes, we only need a reference to a single node, because then the first node points to the second, and the second points to the third, and so on. So we only need to keep track of one. And then we'll also keep track of the number of entries so that we can keep track of how many elements are in our bag. Remember that a bag is an unordered collection of objects. Now, if we scroll to the bottom of this class, you'll see that we have a nested private inner class called node. And here we have two instance data variables, data and next. So these are the things that describe a node. Remember, a node is basically just made up of two pointers. One is a pointer to some data, so that's to your actual object, and one is a pointer to another node. So this is where we say the first node points to the second, and the second node points to the third, and so on. We have two constructors, one that just takes the data and then specifies the next node as null, and another constructor that allows you to specify the next node that the current node points to. We don't bother with getters and setters in this implementation because since this is a nested inner class, we can access these variables directly. And you're more than welcome to do this. You do not need to make these private and provide getters and setters and then invoke set and get for data and next. I know the book does that, but I find it a little tedious, and so you are welcome to just directly access data and next in your code. Okay, scrolling back up, we've got our constructor, which all it does is initialize an empty bag. So with an empty bag, there's no entries, and that first node is just going to point to null because there's nothing yet in the bag. Some of our methods here are pretty straightforward, so it's empty if there's nothing in the bag. The capacity of this bag is going to basically just be as high as we can count. So it's going to be number of entries can get up to be the max value that an integer can store, because there's no limit in a linked chain on how many things we can add, like we had a limit with the array implementation. Current size. Okay, now here's where we get into the meat of it, the add method. So with the add method, we take in a new entry. And remember that because bags are unordered, doesn't matter where we store it in our chain, right? Because we don't have to preserve order. So let's make it easy on ourselves and store it in the easiest place. The easiest place to add an element to a linked chain is actually at the beginning of the chain. So what we can do is we're going to be given a piece of data, an object, and what we'll do is create a new node that describes that object. And then we will just point that new node to what used to be the first node in our chain. Okay, so this is a new node, and we're saying our new node now points to what used to be the first node in our chain. And then we take the first node in our chain and we point it at new node. Okay, so for example, and excuse my really crass way of illustrating this. Okay, if we had, and just this is just going to be my little shorthand for we had a node A that points to B, that points to null, and we had two elements in our list. We want to add a new entry C. What we would do is create a new node for C, and here in our old linked chain, we have first node that points to A. Okay, so this is our data. I'm not actually drawing the nodes, I'm just drawing the data, and first node points to A. So if we want to add a new element, we create a node for it, and then we set the next to be what first node points to. And then we say, okay, first node no longer points to that, now it points to this. So now we have a reference to our new first node in the chain, and the first node points to the second node, which is the old first node in the chain, and the second node points to the third node, and that's our whole list. Okay? And then, of course, we also update, increment, rather, number of entries. Now, this also works if our chain is currently empty, because this would be creating a new node and then saying new node.next would be null, because if our bag is empty, first node's going to be null. So it works in that instance too. Remember, we always need to make sure that our code works when our data structure is initially empty. So that is our add method. We have our toArray method. What the toArray method does is it uses a local current node variable to point at each element in our chain. So we start off where current node points to first node, and we cycle through as long as current node is not null. Note that we don't need the second check in the while loop. It explains in the book that this is not necessary. You'd be totally fine with just cycling along this one single check. And so each time through the loop, we take the result at that place in the array, and we store the data that current points to. And then we move on to the next place in the array, and we increment, or we advance rather, current to point to the next node in the chain. So current starts out pointing at first node. We get the data at that first node, put it in our array. Then we advance current to be current.next. So this is advancing the reference of current to point to the next node in the chain. And then we do it again. As long as that's not null, we get the data from that reference, put it in the array, and then move current to point to the next link in the chain. Note that this does not alter the chain at all. All this line does is make an alias out of current node and first node, and then we advance current node saying, okay, now current node points to current node.next, and current node.next, and current node.next, and so on and so on. We do a similar thing with the current node variable to get the frequency of an entry. So we define current node to point to first node, and then we just cycle through as long as current doesn't point to null. At each time current points to a node, we check the data, see if it's what we're looking for. If it is, we update the count, and then we just advance the current node to point to current node.next. So this is, you're seeing clearly a very common structure for iterating through a chain of nodes. It's something you should get very, very familiar with. And it's something, if you have questions about, you should definitely post them very soon, because this is something we'll use a lot when working with nodes. Contains, not surprisingly, same kind of implementation, right? We have a local current node that points to first node. Then we just cycle through as long as we haven't found what we're looking for and current node is not pointing to null. We check the node we're looking at. If it's equal to what we're looking for, we found it. Otherwise, we advance to the next, and we just keep going. Now, here we have a private helper method called getReferencedTo. So we had some private methods in ArrayBag. We're going to have different private methods in LinkedBag. GetReferencedTo, what it does is it allows us to send in a piece of data and get back the node that refers to that data. So remember that with our linked chain, we always have kind of two parallel chains going on. We have the actual objects themselves, and then we have a node that points to each object. So if we want to look for an object, we sometimes need access to that node, and we need that for the remove method, which we'll look at in a moment. So we implement this method. First of all, I should say, make sure you understand what this method does in terms of it's taking in a parameter of type T and returning a node. Make sure that whole idea makes sense before you even think about the implementation. For the implementation, we're going to do something very similar to what we've been doing. We're going to take current node and point it at the first node, and then as long as that current node isn't null, we're going to cycle through and say, okay, is the data that I'm looking at equal to the node is the data that I'm looking for equal to the data at my current node? If it is, then I found what I'm looking for. If not, I'll keep on looking. And because I exit this loop as soon as I found what I'm looking for, I can just return whatever current node pointed to once I exited the loop. Okay? Okay. Moving down, clear is a pretty simple implementation. Okay, so now we have the remove method that returns data of type T. So here, what we can do is, again, remember this remove method allows us to remove any object from the bag. Doesn't specify which one, so let's make things easy on ourselves. First of all, let's check and see if there's anything in our bag. So if first node is not equal to null, that means there's something in the bag. If first node is equal to null, there's nothing to remove, so let's just return null, right? That's what we will, if the remove is unsuccessful, we'll return null. But if there is something in the bag, what we can do is we can get that data out of the first node, and then just set first node equal to first node.next. So our first node reference now points to what used to be the second node in the chain, and once this method ends, we now no longer have any pointer pointing at the first thing, and so it gets garbage collected. So this is a really simple way to implement remove, right? So if we pull back up my crude little picture here, all we're doing is we're saying, okay, first node now points to first node.next, which is A. And then now, because nothing points to C, once this method ends, C will be garbage collected. And we've essentially removed one element from our bag. It's a little more complicated if we want to remove a specific element. So remember that the second remove method allows us to specify a piece of data and then remove that entry from the bag. To do that, what we need is we actually need the node that points to that data. So that's where we invoke that private helper method get referenced to. We send in the data we're looking for and we get back a node. And then we check to make sure that node isn't null, because remember, if we did not find a reference that if that element was not in the bag, then the node that's returned from this method is going to be null. But if that's not the case, then node n will be a non-null node. And what we can do, the easiest way to do a removal with this, since again order doesn't matter, is we can just swap the node that we want to remove with the first node. So what we can say is, we can say the node that we are removing, let's put the node of the first data in its place, and then just remove the first node in our chain. Right? So let's say our list stored 1, 5, 6, and 8, and we want to remove the 6. What we're doing is we're just saying, okay, give me the node that references 6. That's going to be this one. And then put first node.data in its place. So take out, actually go to the object. First node.data is the object, node n.data is the object itself, and swap out the data. So this is data as integer, so I'm going to swap that out. And then just take first node and point it to 5, which means nothing's keeping track of the 1 anymore. And so my new bag will look like this. Okay. So again, this all works because order doesn't matter, right? We don't have to care about what order things are in, so let's just make things easy on ourselves. And if we want to remove the third object, what turns out to be the third object in our chain, let's just swap it with the first and delete the first, because we know deleting the first is really easy, because we just did it up here. And that is the full LinkedBag class. Okay, so those are the implementations of the method. Again, it's really important to make sure you understand how nodes work before you can understand how to use them in the implementation of LinkedBag. In the next video, we're going to add 2 methods to the implementation of LinkedBag, but again, make sure you understand how all these existing methods work first before you start to think about adding additional methods.